Hello everyone, my name is Greg, and this is going to be question 2 of the Calculus 2 exam. So we're going to have our multiple equations here, y equals x squared plus 1, y equals 0, and x equals 1 about the y-axis. Basically, we're going to have to find the volume of these two equations making a solid. So basically what we're going to do is we're going to have a part A, which is going to be sketching it out. So we're going to have the following. This is going to be our x squared plus 1. This is going to be x equals 1, which is going to be our cutoff. And now we have an area right here that we can call our solid. The problem is that we have to rotate it about the y-axis. So now we're going to have another graph over here, which is going to show what it looks like if we rotate it. So we're going to have the following. Okay, this is our solid that we're going to be working with. And just by eyeing it, we have a sort of like dip in the shape of the cylinder. So we are going to actually use the shell method in order to find out the answer to this question. So in order to do that, we need to find the upper and the lower limit. And it's given to us actually in the problem. We have y equals 0 and x equals 1. So basically, if we're rotating it about the y-axis, it's from point 0 to x equals 1, 1, which is going to give us limits of lower limit being 0 and upper limit being 1. Okie dokie. I'm going to erase and start writing out our problem. So we have b upper 1, lower 0. Now what we're going to do is we are going to use the shell method. Let's see if the other marker is going to be better. Sorry for switching. Shell method, which is going to be 2 pi r h. So you might be wondering, what are these variables right here? This is going to be our radius and our height, and that's going to be determined by our functions that we already have. So we have r and h equaling the following. So it's going to be as simple as this because we have x equals 1 and y equals x squared plus 1. So we have our x and we have our x and we have our y. So now what we're going to do is we are going to plug this into our integral. And since 2 pi is a constant, we can go ahead and pull it out right off the bat. And we have our upper limit of 0, or our upper limit of 1 and our lower limit of 0. So it's going to be 0 to 1. And then we're just going to have x times x squared plus 1 dx. Cool. We have our integral now. All we have to do is distribute this right here, and then we'll be good to go. So what we're going to do is 2 pi 0, 1. We're going to distribute that. X cubed plus x dx. And that looks pretty easy. All we have to do now is basically just integrate it. So we're going to have 2 pi x4 over 4 plus x squared over 2 from the lower limit of 0 and the upper limit of 1. So just plugging these in, it gives you a very simple answer, which is going to be 2 pi 1 over 4, because 1 to the power 4 is 1, and 1 over 2. And since 0 divided by anything is 0, we're not going to have anything for the lower limit. So it's going to be 1/4 plus 1/2, which equals the following. 2 pi 3/4. Now if we multiply these two, that's going to give us 2 pi times 3. It's going to be 8 pi over 4. And when we divide by 2 on the top and the bottom, it's going to give us a final answer of 2 pi. Nope. Yes. That's going to give us, that's not going to give us that. It's going to give us so pretend I didn't do that. We're going to have 6 pi over 4 instead of 8 pi over 4, my apologies. 2 times 3 is 6. And that's going to give us an answer of 3 pi over 2. Now the reason why it is solely 3 pi over 2 is because it's a definite integral, therefore it doesn't need a constant of c. So our final answer for question 2 is going to be 3 pi over 2.